Jai Hind to all. I'm Dinanath Prasad. Today I'm discuss Unit 2 topic of Energy Science and Engineering. This topic in this unit I will cover basically first of all I will cover the basics physics behind the nuclear energy. What are their contents are is to be required to understand the nuclear energy. So first of all, I will cover here. There is fundamental forces which is available in the universe. So there is basically four fundamental forces which is available in the universe. That is gravitational force. Sorry, these are gravitational force, weak nuclear force, electromagnetic force, and strong nuclear force. So these are the four forces which is available in the universe, which is not visible to us, but they are always acting in a universe. So if we talk about the weak and the strong forces is available with the very short range and dominant only about the subatomic particle, and other forces like gravity and electromagnetic forces that having infinite ranges. So if we talk about the characteristic of these forces, or like gravitational, weak, electromagnetic, and the strong nuclear forces. So gravitational forces having called as weakest force, but if we talk about their range, they having infinite range. If we talk about weak nuclear force, this is next weakest to the gravitational force, but it having short range. The electromagnetic force, it is termed as a stronger force, but it having infinite range. And another one is the strongest force, or generally it is called as nuclear force. This is the strongest among all, but it's talk about range, they having shorter range. If we go to more descriptive way of different type of available forces, that is gravitational forces, it having long range. This forces is available due to attractions of the two body having different mass. This is always available in the nature. So this is always available, but they have been termed as a weakest force. Another force is weak nuclear force. This is due to the nuclear decay, or generally it is due to the beta decay particle, and it is also characterized as a short range of forces, or you can say very short range of forces is known as weak nuclear force. Another one is electromagnetic force. This electromagnetic force causes due to the electric field and the magnetic field, and by the attraction or repulsion between the electric charge, like positive to positive charges, positive to negative charges, and negative to negative or negative to positive charges. So it can be attractive or repulsive and acts between the two pieces having of matter carrying an electrical charges basically. And this is by the electricity, magnetism, and light has produced this kind of forces. Another forces that is termed as a strong nuclear force or nuclear force. This is having very short range but very strong. They basically due to the electron and neutrons, electrons and protons are bound together in a form of glucons. In a glucons, when two particles interact, they are termed as a strong force, but it having called as short or very short range forces. If we talk about their range comparative table, we can understand with this table that is gravity that is acting between the two masses, weakest force governed by the particle decay, electromagnetism act between the electrical charge particle, and short ranges that is bands going together. So these are the range that having infinite range gravity, weakest force, weak force having short range, electromagnetic having infinite, and the strong force having short range. If we talk about relative forces, it is going from the gravitation to a strong. Their strongness will become increased. So this is very well topic to understand about before going to the main topic, nuclear energy. So first of all, I will give you some basics physics about the structure of atom, and which have to be known to everyone. What is the structure of atom? So this is the basically the summary of all. So every atom consists of basic entity called elements. Each element composed of a smallest particle, that is called atom. Atom consists of positively charged nucleus at the center and negatively charged electron which is revolving around it. We know that the radius of atom is 10 to power minus 10 meter, and the radius of nucleus is 10 to the power minus 15 meter. So, and another thing is to be remember is that the nucleus consists of proton and neutron, which together is known as nucleus. Another thing is to be notice that the mass most of the mass of the atom possessed by the nucleus. Electric charge of proton is equal but opposite sign to the electron, and the atom as a whole is electrically neutral because number of proton and number of electrons are equal. So this is electrically neutral. Other thing is to be remember, like this is the representation of atom. We will represent atom like in this way, or we can represent as by this way, and this can be also represented as this way. So these are the different type of representation where this A is known as the mass number, and the Z in the lowermost point, this is known as atomic number, and this X represent the symbol of any element. So what is atomic number? So it is defined as the number of proton in an atom is called as atomic number. If we talk about mass number, it is represented as total number of proton and neutron in an atom. It is known as mass number. And another thing is to be remember, always remember, mass of neutron is this much amount of kg, and it is represented as AMU, that is 1.008654 AMU, or it is represented 1.67 into 10 power minus 27 kg approx. Mass of proton is 1.007277 AMU, and this much on kg. Mass of electron is this, and in kg it is 9.106109 into 10 power minus 31 kg. And what is AMU? It is represented as atomic mass unit. It is 1.66 into 10 power minus 27 kg. And another term, it is defined as AMU is 1/12th of the mass of the common carbon atom. Hydrogen is only atom that having no neutron. So another thing is to be noticed, that is isotopes. What is isotopes? Isotopes having same atomic number, like, or another term, it is same number of proton. It is called the isotope, but it having different mass number or nucleus, like this carbon atom having 12, 13 and 14 14 nucleus, but having the mass number is same, that is 6. Another thing is the deuterium. It is having same example of that. Different isotopes of uranium are available. Like another terms which is point to be remembered, that is isomers. Isomers having same mass number but having different number, like this. These are the examples of isomers having different atomic number. Another thing is to be notice what is nuclear force. Nuclear force, generally it is one of the four kind of fundamental force, or it is called as strong nuclear force, which is available in the nature, which is in fact it is called as 10 million times stronger than any chemical bond. They are termed as a strongest force. The nuclear force is acts between the proton and neutron. They are glucons to the together together. So a strong nuclear force, uh, mm, I will talk about a strong nuclear force and weak nuclear force. It is a strong nuclear force is name implies it is the strongest of the all four fundamental forces amongst all uh, available in the nature. This is also called the highest strongest force, but have it having lowest strengths. Another one is big nuclear force, or big interaction force, having like due to the beta decays. uh, Another term is to be noticed, that is what is mass defect and the winding energy. So we defined basically winding energy is the energy required to break a nucleus into constituent of proton and neutron. It is the system is separated nucleons that having greater mass than any than a system of wound nucleons. So the force will be available in any nucleus to whatever be the energy is applied to the nucleus to break into the proton and neutron, it known as the binding energy. Another term is mass defect. Mass defect is defined as the sum of the masses of the proton and neutron, which is comprises the nucleus exceed the mass of atomic nucleus. This is the difference, that is the actual mass of the any atom and their practical mass uh, of the any atom. That difference is called as mass defect, and it is represented as delta m, that it is mathematically represented like in this form, that is mass of neutron, mass of proton, plus mass of proton plus mass of electron into the atomic number minus this weight, actual weight, and that difference is known as mass defect. And mass defect is converted into energy, that with this equation, or with this formula, we can calculate the binding energy, which is defined as delta E, that is change in mass into c square, and uh, uh, c is known as velocity of light into this is 3 into 10 to power 8 meter per second. So with this we can calculate the mass defect, and with this formula we can calculate the binding energy. So with this we can calculate uh, with to understand better understanding of binding energy and mass defect, we have taken our example, that is mass of helium, that is around 4.00837 AMU. We have to calculate the mass defect and the binding energy as the given in this formula. Given the mass of neutron is 1.008654 AMU, and the given mass of proton is 1.007277 AMU. Mass of electron is given 0.005486 AMU. So we have to calculate the mass defect and the binding energy. As in this problem, given the mass of helium and is 4.00837, and the mass of helium we can calculate as mass of helium atom minus mass of 2 orbital electron, which is calculated as 2 into the mass of mass of electron. So with this we can calculate the mass of helium nucleus, then mass of proton and neutron of the nucleus we can calculate it simple by the formula, and then after we can calculate the mass defect, that is 4.031 minus 4.0027. This is the mass defect, that or it is represented as delta M. And for calculating the binding energy, we multiply this mass defect, that is delta M, into C square, and this is in terms of million of electron volt, that is 27.084 million of electron volt is the binding energy. But if we want to calculate the binding energy per nucleon, we divide it into the mass number. So with that we can calculate the binding energy per nucleon. So binding energy per nucleon for deuterium is 1.15 million of electron volt. In this way we can calculate the binding energy per nucleon for the all isotopes. Uh, Another thing is about the binding energy is that with the help of binding energy per nucleon, basically it decides the stability of the nucleons. Higher the binding energy per nucleons, it gives the higher the stability of the nucleons. Another term which is important in terms of basics of nuclear energy about the binding energy curve. What is binding energy curve? Basically, binding energy curve is represented in terms of binding energy per nucleon versus the mass number. So, with this curve, we can differentiate which atom is suitable for the fusion kind of a fusionable material, which kind of material are suitable for the fusion material. So basically, for the masses having lower atomic weight, like hydrogen, helium, lithium, they having lighter mass number. They having mass number is lower. So the for the fusion, it is suitable uh, for the fusion reactions. Basically, in the fusion reactions, lighter masses are combined for the for the and this is suitable for the fusions. And for the fusion reactions, those atom having higher mass number, like this uranium having higher mass number, so this is most suitable for the nuclear fission reactions. And for the atom having something like a stable in nature, like iron having termed as a stable atom.